Hi friends, today we are thinking about how to prepare for PP2, especially for 2 mark question. In case of 10 marks and 5 marks, we have a clear cut idea. Whatever it is, if it is asking for 5 of 10 of 2, if we are adding good presentation, that is like with the help of a diagram or with the help of an equation, it will give clear cut 2 marks. So let us have a journey how we can prepare for PP2 for 2 mark, especially we are focusing on the drug stability and micromeritics chapter. So this may be the important short answers, many are there. We are just discussing about a few. First one, explain the percent log normal distribution curve. So in that we can see that in the chapter micromeritics, the powders based on the particle size distribution, many curves are there, like frequency distribution curve, normal distribution curve, and log normal distribution curve for a powder. Among this, the most important one is log normal distribution curve. So in this question, you have to focus. First, you have to draw this diagram. In this type, we can see we have to plot the percentage frequency on the y-axis against log mean particle size on the x-axis, which we are determining in terms of micrometer. And we have to mention that advantage of this curve is that we can see a symmetrical distribution in this particular curve when we compare to a normal distribution curve. And we can see this type of log normal distribution curve in powders that are obtained by crystallization and milling methods. Next question is about explain the ferrite diameter as well as projected diameter. So we know that some popular methods are there to express the particle diameter by microscopic method. So first, for the purpose of measurement, we have to draw a diagram to explain the same. So popular measurement for expressing the particle size are projected area diameter, which is expressed by the 1, second one Martin diameter expressed by 2, and ferrite diameter expressed by this 3. So first of all, what is projected diameter? So our question is explain ferrite and projected diameter. So projected area diameter means here we know we are drawing in shape of a circle, right? So it is the diameter of a circle with the same area as that of the particle observed to the surface. That is, the diameter of the circle we are thinking it is having the same area as that of the particle observed. And second one is Martin diameter. Martin diameter means it is the length. So here we are noting what? It is the length of the line. So in this we already mentioned the surface same area we are considering in case of projected area diameter. In case of Martin diameter, we are drawing a line that bisects the particle image and we are noting it as Martin diameter. Whereas in case of ferrite diameter in our question, so we are drawing what? We are drawing two tangents. Two tangents like this on opposite side that are drawing parallel. And we are determining the distance between this is expressed in by 3, distance between the two tangents on opposite direction of the particle parallel to a fixed direction. So we have to draw this diagram and explain the 3 possible or popular measurement. Next question, give packaging arrangement of powder. As we all know, we can pack the powder in different ways. If it is properly packed, only we can see a proper distribution characteristic. For example, if the powder is not properly packed, we cannot get a uniform size particle, or it will not give a proper value. So in such case, first we have to tell the arrangement of the particle influences the volume occupied by it. So if the particles are having the uniform size of sphere, we can see two types of packaging arrangement. One is known as the closet or rhombohedral packaging, and second one open or cubic packaging. In case of closed packaging, we can see the porosity of the powders are about 26%, and in case of open or cubic packing, we can see a porosity about 48%. Normally, if the porosity are above 15, we can tell that some aggregation or flocculation happen in that powder. Next question, what is the rate of flow of powder and explain Karl index? As we know, the flow property which will affect the flow, that is especially if the flow is not regular, we cannot achieve a content uniformity, especially in case of tablet. So how we can determine this flow characteristic? The flow characteristic we are mainly measured with the help of angle of repose. The angle of repose concept is very important in the aspect of theory as well as practical. So angle of repose we can determine in terms of theta is equal to tan inverse h by r, where theta is the angle of repose, h is the height of the pile, and r is the radius of the pile. Our next part is explain the Kahn's index. In case of Kahn's index, it is otherwise known as Kahn's consolidation index or compressibility. So the equation is that tapped density minus fluff density by tapped density. So this Kahn's index we can tell is a popular method for predicting our flow characteristic. Going to the next question, define the bulk density as well as true density. It is also coming under our microanalytics chapter, and we are doing the same in the lab also. So here different density we have studied. They are asking about define the bulk density and true density. So this density coming under derived properties of powder. What is fundamental and derived properties are also important. So our density we are deriving from a property, that is, for example, bulk density rho is equal to mass of powder by bulk. So we are deriving with the help of two powders. So we can tell this as an example of derived property. Fundamental means what we are getting actual is fundamental property. Then telling about the true density, it is the density of the material itself. So true density is equal to weight of the powder by true volume. So we can determine our true density mainly with the help of helium displacement method as well as liquid displacement method, and we are determining the bulk density with the help of bulk density apparatus, or we are determining manually also. Next question is about define rate and order of a reaction. So it is coming under the chemical kinetics introduction part. So first we have to know what is rate. Reaction rate or rate of reaction means what is the speed at which our chemical reaction takes place. So this reaction rate will be proportional to the increase in the concentration of a product per time. So the rate or velocity we can express in terms of plus or minus dc by dt, where dc is the change in the concentration with a respect to time interval dt. Whereas order means what? It is the power dependence of the rate on the concentration of the reactant. So if it is first order, if you are giving one exponent, this is a sum of one exponent only, right? So order of the reaction is defined as the number of concentration terms on which the rate of reaction depends upon when we are determining experimentally. Then next question, what are the pharmaceutical specification of the storage condition for pharmaceutical? So different are the we can store our product in different method. That is also a question. More than that, this is a question regularly asked. What are the pharmaceutical specifications? So as a pharmacist, we have to know under which terms we are telling what are the storage conditions. For example, if it is cold meat, that product should keep at a temperature between 2 to 8 degrees Celsius. Where if any products having a labeling of cool, it should keep in between 8 to 25 degrees Celsius. And in case of room temperature means the temperature in our working area, and warm means 30 to 40 degrees Celsius, and excessive heat above 40 degrees Celsius. So we can see these terms in case of our IP. But these are other two terms which are now prescribed by IP, and just mentioning we have to know, right? So control temperature means we can see these two terms in USP, that is the working environment. 20 to 25 degrees Celsius is control temperature, whereas freezer means we are keeping the temperature thermostatically between minus 20 degrees Celsius and minus 10 degrees Celsius. Next question, differentiate between the half-life and shelf life for a first order reaction. So we have to know what is the difference between half-life and shelf life. So half-life means the time required for the concentration to reduce half. For example, if A reduced to 50, and if 100 is the concentration, reduced to 50, that is the time, that is half-life. But shelf life means the time required to reduce the concentration of the reactant to reduce to 90% of its initial concentration. So half-life we can express by T half is equal to A by 2K0, whereas shelf life T 90 as subscript is equal to 0.1A divided by K0. Next question is also important. Give Arrhenius equation and its significance. So it is a term that is related to the effect of temperature on the rate of reaction. So according to the scientist Arrhenius, for every 10 degree Celsius rise in temperature, we can see the speed of reaction proportional about 2 to 3 times. So we are expressing with the equation K is equal to AE raised to minus EA by RT. Where capital A is the Arrhenius factor, EA is the activation energy, RT is the ideal gas constant. And Arrhenius factor, if I am taking in log term, it becomes log K is equal to log A minus EA by 2.303 into RT. So we can draw a graph by taking this log K on the y-axis and reciprocal temperature on the x-axis. And we can obtain a straight line also, and we are getting the intercept correspond to log. Next question, what are the different expressions for the rate constant and half-life of zero and first order reaction? These are the K means rate constant and T half is the half-life. So we have to know this equation, then only we can explain another 10-mark question. They are asking to write about the zero and first order, what is a half-life, rate constant, like that. I think this video is helpful for you. If you find it useful, please share it to your friends. Thank you for watching.